Chapter 2 pretty much picks up where chapter 1 ended. Okay, so chapter 1 and chapter 2 are really one big chapter. We just separate them because it gives you a better chance. The more tests you take, that's the thing. That's the thing. In any class, the more tests you take, the better chance your grade has of going up. So you want to take more tests. So that's why I split up chapter 1 and chapter 2, not make one big chapter. Okay. So chapter 1 and chapter 2, but really I could have made them one big chapter. Okay. But I try to do that so that you guys gives you more opportunities to makes it a little easier because chapter 1 is not as big. Chapter 1 is a little bit bigger. Chapter 2 is not very long. We're going to go through chapter 2 pretty quickly. There seems like a lot of stuff, but it's really not. Okay. All right. First thing, percentiles. Very first thing. One of the most it's misinterpreted, I should say. Misinterpreted. One of the most misinterpreted things anywhere is the word percentile. People see the word percent, the first part of it, and they think, oh, it's a percent. Yeah, but it's really not a percent. Okay? So percentiles, we're going to see percentiles. What is a percentile? What's the difference between a percentile and a percent, right? On my group test, I got a 99%. That doesn't mean you're in the 99th percentile. Okay? Those are totally different. Okay? So percent is what you got on your group test. How many points did I get divided by 28? And that's your percent, right? That's a percent. Percentile is different because a percentile compares you to everyone else who took the test, compares you to everybody else. The pth percentile, it's a number of a distribution is divided at the value with p percent of the observations less than or equal to. So if you got a 99%, you weren't in the 99th percentile, okay, of this group test because a lot of people did well. A lot of people got over 100% because of this guy right here. There was extra credit here, that 2 points there, and then you got extra credit here. So there was 2 points, 2 places to get extra credit. So percentile is what percentage of people in the group did you tie or beat? So if you're in the 90th percentile, you tied or beat 99% of the other people who were doing whatever it is you were doing. Okay? Whatever it is you're doing, right? Whatever it is you're doing. That's what percentiles mean. It's not percentages. It's based off a percentage, but it compares you to everybody else. When you take standardized testing, tests, SAT, ACT, SBAC, AP, any of those types of things, you get a percentile. It compares you to everybody else who took that same test. Okay? When you're little kids, babies, toddlers, you go to the doctor every month, every year, whenever the doctor wants to check up on you. First thing they do is they measure you. They measure your height. They put you on the scale, measure your weight. And then they come back and they give you a piece of paper, or your parents a piece of paper, and it says your statistics on there. And it's a percentile. What percentile are you in? Are you in the 60th percentile? That means every baby they've ever measured that's ever been made, put in the database. So every baby that ever goes to a doctor in the United States is put into a database, and they compare you to them. So if you're in the 60th percentile, that means out of all kids your age, you're taller than or way more than 60% of them, above average. Okay, you're above average. It compares you to everybody else. So example, I scored in the 95th percentile on the English portion of the state test last year. What does that mean? That means my score on the English state test beat or tied 95% of the people who took the same test last year. That doesn't mean you got a 95. Okay, some people see 95th percentile, they're like, oh, I got a 95 on the test. No, you could have got 100. You could have got a 50. You could have got, I don't know what. Okay, so it just compares you. That's all it does. Percentiles just compare you to everybody else who did the same thing, took the same test, weighed the same amount, was the same height, whatever it was. Okay. All right. So let's do an example here. The stem plot below shows the number of wins for each of the 30 Major League Baseball teams in 2009. Okay. So there's 30 scores here. There's 30 scores. 5/9 represents 59 wins. Okay. Calculate and interpret the percentiles. For the Colorado Rockies, they had 92 wins. The New York Yankees that year, who had 103 wins. And the Cleveland Indians, who had 65 wins. Okay, so we'll do the first one together. The first one is the Rockies. The Rockies. They had 92 wins. Okay, so go with your pencil, go find them. Go find them on the plot, the stem plot. Oops, let's see. Right there. That 2 and the 90, that's them. That's the Colorado Rockies. Okay. So how many people did they tie or beat? How many teams did they tie or beat? 24 teams. Okay. So everybody who they had more wins than had a lower number. So this team who had a 91, 88, 87, 87, 87, 86, 86, 85, 80, all of these teams here, they tied or beat. There was only 192, so that was them. Okay, but everybody else here, they beat, right? So we count all those, and that's 24. Okay, let's see. 1, 2, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yep. So let's see, Colorado Rockies. So they tied or beat, that plus 24 out of how many teams? It said there were 30 teams, right? It said there are 30 major league teams. So out of 30, then we go to our calculator and give me a decimal. So go to your calculator. What's the decimal going to be? Go 3 places if you can. If you can't, go as many places as you can. 0.8, right? Just 0.8. 0.8. You can't really go, and it's 800, so we just stop at 8. That's the 80th percentile. The 80th percentile. In 2009, they were in the 80th percentile. Okay. Now what I want you to do is do it for the Yankees and then the Cleveland Indians, who are now the Guardians. Okay. So New York Yankees. I want you to do this on your own. I'll give you about 2 minutes to do this. So frequency. What's the first table frequency? So what'd you get? 1. Good. The next one, 60 to 69. 4. Yeah, it's kind of already nice because they're already broken up into tens, right? So our interval, it was nice that way to use it. So 70 to 79, let's see what we get. 8. Sorry. And then 10, 80 to 89. 6 for 90 to 99. And then 103 or 100 to 109 is just 1, right? So total we should have 30. 22, yep, 30. Relative frequency. Okay, so for the first 50 to 59. How do I find relative frequency? So I got 1, and I'm going to divide it by 30. Good. 0.033. Don't change it to a decimal or percent. Just leave it as a decimal. Okay. 4 divided by 30, I get 0.133. 8 divided by 30, I get 0.267. 10 divided by 30 is 0.33 repeating. 6 divided by 30 is 0.2. And then 1 divided by 30 again is, okay. That's where we stopped. We graphed it using a histogram. We stopped, right? That's where we stopped last chapter. Well, for this graph, we need one more column. One more column. Cumulative. What does cumulative mean again? What is the word? If I add the word cumulative, what does that mean? Not percentage. It means adding up, total. You're adding up. It's a running total, right? So after the first interval, how many do I have? What relative frequency do I have? After the first one. I'm through 50 to 59. What is my relative frequency so far? I'm going to say add. I'm just saying my question was, when I'm through the first one, how much is my relative frequency? There you go, right? I only have one. So you can't add it with anything. Now, after I'm through the second one, how much do I have so far? I'm going to add them together, right? What did I have to begin with? 0.033 plus what I have to go through, 0.133, and you get 0.166. Okay, so 0.166, I'm through two intervals. Let me go through the third one. 0.166 plus the next one, 0.267, 0.433. Okay, now add the next one, 0.333. Should go up because it's a running total. Then add 0.2. And then the last one is 0.033. What should it add up to or be very, very close to at the end? One whole. One whole. Mine is not one whole. Is that okay? Mine is 0.9999. Is that okay?
Yeah.
Why is that okay if it's not one? No, it doesn't have to do. I wish I was a baseball player, professional baseball player, but I'm not, so I'm not in the list. So why does 0.99 okay? What can anyone explain why it's 0.99 instead of 1.0? That's what John just said. No, it's not that.
Because one numbers like, for example, 1.33 will continue off, so we just have to go with 1.33, and then we can't just have like that forever.
Yeah, what is that called? Exactly what you were just saying. There's another word for it. Starts with an R.
Oh, I don't remember it. All I know, I just put a line above the 3.
So when you do that, yeah, what is that called? Starts with an R. Not repeating. These numbers didn't end there. I stopped writing. What is that called? Rounding. You rounded them, right? This goes on forever. This goes on forever. This goes on forever. This goes on forever. This one goes on forever. These go on forever, right? I just stopped writing because I rounded them, right? That's why, because of rounding. So 0.99 is okay. 0.1001 is okay. Now, if I added all these up and it was 0.899, that's not okay. Then something's missing. Okay, so last thing. Let's go graph these. So I need to graph these guys here. Very last thing we're going to do. These guys are going to be right here. So I got a number. Most of the time, you number the same way they did. Okay? Number the same way they did. They went by 0.1. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. I'm going to run out of space. 0.8. Shoot, start this over. Ran out of room. Let me try this again. Same rounding, I just got to put them a little closer together. Okay, let's see. 0.2, 0.3, 0.5, no, 0.4, 0.6, 0.8, 1.0. Okay, so that looks just like theirs. I just numbered the ones from 0.2, but it's 0.1, 0.2, 0.3. Okay, so the first one, the first cumulative is 50 to 59. 50 to 59, and that one is right here. Where does that dot go? Below even 0.1, barely anything. Right there. Right there. Where's the next one go? About halfway between here and here. Connect the dots. Okay. Make the others. 0.433. 0.433 right there. Let's see. 0.76, big jump here. Almost 0.9, another big jump. Or almost one a whole. And then the last one is here. Okay. Do that, we're done. We'll talk about it. We'll talk about what it means tomorrow. Okay. No new assignment today, but there will be a new assignment tomorrow. Okay. So nothing new today. There will be one after tomorrow. Okay, so since the Yankees tied or beat 29 other teams, because they are the team with 103. So if you were to count up all of these that they tied or beat, they didn't tie anyone, but they beat 29 other teams, you'd get 29 over 30. 29 over 30 is the same as 0.967, which is approximately the 97th percentile. The Cleveland Indians tied one team because they had 65. There were two 65, so they must have been one of them, and another team was another. So they tied or beat 1, 2, 3, 4 teams. So 4 divided by 30 is 0.133. So that's about the 13th percentile. Okay. Ogive graph. An ogive graph is a cumulative relative frequency graph. So the data is from the median household income for 50 states and the District of Columbia. So California has a median household income of $57,445. At what percentile is it? Well, here are the percentiles here. On the x-axis are the median income. So we're going to go find the median income since that's what they gave us. So 57,445. So 57,445 is around right there. So what we're going to do from there is extend up until we reach the graph there. To find the percentile, we're going to go one more time, but we're going to extend to the x-axis, or the y-axis, sorry. Okay. So it's around 80%, around approximately 80th percentile. So interpret this value, we would say California's median household income is in the 80th percentile. They're in the top end. Makes sense because homes in California cost a lot of money. So if homes in California cost a lot of money, people are going to need more money to buy homes or to rent homes. So people who live here who are going to be on the higher side as opposed to states that don't cost as much money to live in. Okay, the 25th percentile. So we have the 25th percentile, the 25th percentile. So now they give us the percentile. So we're going to start over here. So 25th percentile is right here. So now we're going to extend first to the right, and then I'm going to extend down. That median income goes with the 25th percentile. So approximately $45,000 is the 25th percentile. Now percentile, 25th percentile means whatever state this is, tied or beat 25% of the other states. So another word for the 25th percentile is Q1, because Q1 is 25%. So we would say Q1 is about 45,000. So the steepest part of the graph. So the steepest part of the graph, I would say, is probably here in the green. Right there in the green. The non-steepest, or the lowest slope, is probably in the yellow. So what causes the green and what causes the yellow? Well, it's just like a box plot. It's just like when we have a box plot who has these tight windows. It means there's a lot of data gathered in that area, as opposed to more spread over here. So we say that it's steepest from 45 to 50 because there are many states with medium income values from the green, which is 45 to 50. 45,000 to 50,000. And then the yellow, it doesn't ask us this, but it does say, but it's a potential test question. Why is the yellow not steep? It's the most constant. It almost doesn't increase at all. It's because there's not many states that have 35 to 40,000 that fit into that category. There are a few, but not many. Okay. And then the last thing is what we call an ogive graph. So doing the graph from hand. So to do the graph from hand, you need, just like you're setting up a histogram, you need intervals. You need frequency. You need relative frequency. And then the only new thing is a cumulative relative frequency. So when I add the word cumulative in there, all that is doing is a running total. So after the first interval, we only have 0.033. But then after two intervals, I have my old one plus my new one, and that makes 0.166. And then after the third one, you have your old one after the second plus your new one at the third. You add those together and you get that. So you keep doing that until you get all the way to the bottom. You're going to get 0.99 or 1.0, something close to that. And then you just go make dots. So you just go make dots after you label your graph. So I labeled the x-axis by tens. I labeled the y-axis by 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Made dots, so this is the first category. The first one, and then the second one, and then the third one, and then so that's how you make an ogive.